Hi, I'm Tom Zimmerman. This is the second episode on predictive processing as a way of updating our metaphors for the neurobiology of trauma. In order to understand predictive processing, it's helpful to understand the classical view of perception because we're about to flip it on its head. Until very recently, we had a bottom-up view of perception where our senses gather raw information from the world and process that information in a linear manner, deeper and deeper or higher and higher into the brain until it's finally interpreted deep in the brain as a meaningful perception. So, taking vision as an example, we assume that light comes in through the eyes, hits the retina, and the information is converted to electrical impulses. And this data is sent first through the lower levels of the brain where lines and edges are detected, and then other levels may process color or movement, and then deeper levels may detect objects, and eventually a scene containing meaning emerges into awareness. This version of the brain moves in a feed forward process. And until relatively recently, it was the predominant understanding of perception. It lines up well with the intuitive feeling of perception, especially when compared to the view of perception that I'm about to communicate. In this classic view, perception is largely a direct and reasonably accurate reflection of the external world as it is. The brain functions in this example in the following order: see, interpret, and then act. The brain is largely a reactive system, processing information first through lower levels and then toward higher levels. Advances in brain imaging, mapping, and modeling have allowed us to see clearer than ever the structure of the brain, the highways of information flow, and the direction of that flow. So, from the classical model that we just described, we would expect to see large pathways flowing from the sensory regions, routing information higher and higher, deeper into the brain. But that's not what they're finding. In virtually every sensory system, larger pathways seem to move information in the opposite direction, from deep into the brain, deep in the brain, moving information down toward the sensory regions of the nervous system. For some of the sensory systems, the ratio of the flow of information moving down toward the sensory regions from the higher brain regions outnumbers the flow moving up by a ratio of 4 to 1. What the heck is going on here? Why is information deep in the brain, so much of it, being sent down toward the sensory regions in such a pronounced and unexpected way? It's almost as though the higher regions of the brain are informing the sensory regions about what they should perceive. And that just can't be. That's not how perception feels to us. And as we'll see, how things feel to us is just one of the last magic tricks in the sequence of them with a brain wired this way. So, a newer model of perception and cognition is becoming a dominant view in a multitude of neuroscience fields, especially cognitive neuroscience, computational neuroscience, theoretical neuroscience, affective neuroscience, and clinical neuroscience. This newer model goes by multiple names because it has multiple Edens. Predictive processing framework is often used interchangeably with active inference, Bayesian brain, predictive coding, and hierarchical predictive processing. In summary, here's the model in just a few core parts. Part one, we hold inside us an enormously rich internal model of the world, which includes ourselves. From before we're born, Our brains were wired to model the world from what we'll sense from the world. But we aren't born with much of a starting model. So we have to use our senses to build it before we can use the internal model to predict it. This modeling depends on some statistical probability that emerges, for instance, from the voices it hears and other environmental features. After birth, new statistical probabilities emerge because we're generally a predictable species. A baby brain learns that certain sounds tend to come together. Pretty baby and want a bottle, and that certain actions tend to follow. Out of the lines and contours, a brain learns to identify faces and objects and starts to build rudimentary concepts and constructs. From statistical probability, it will continue to build a massive model of the world that includes complexly related concepts. Concepts like therapist, EMDR therapist, professional, Zoom, presentation. So, in summary, we hold inside us an internal model of the world made of all of our experiential learning. And throughout this series, I'm going to describe that as the generative model of the world. That's how it's described in some of this literature. Part two, beneath conscious awareness, the brain generates a large number of predictions about what it expects to sense based on everything it's ever learned about the constructs relevant to this context. These predictions are blindingly fast and they're largely unconscious. It sends those predictions toward the sensory regions of the nervous system. Part three, the incoming sensory information is compared with the predictions, and discrepancies are registered as prediction error. Prediction error signals are sent back up to the higher regions of the brain to either generate refined or updated predictions or begin the process of updating our internal model of the world. So the goal in a brain organized in this way is to minimize prediction error. So to repeat all of that, in summary, perception begins with an internal generative model of the world built from everything we've ever been through in any context. And from this model of the world, a large number of context-specific predictions are generated. And these are sent toward the sensory regions of the brain to be evaluated against incoming sensory data. When the predictions don't match the sensory information, prediction error signals are sent back up, and these error signals generate either updated corrections or they help you update your internal model of the world. The optic nerves alone transmit about 10 million bits of visual information per second, and the brain couldn't possibly process all of it. So only sending, anticipating, and only sending error signals help save important cognitive bandwidth, much like how video encoding algorithms only send an update about what's different between each of the frames in the video. All of this is regulated by key brain networks that apply precision weighting. It's another term that we're going to explore. With vast amounts of information in your generative model of the world, literally everything you've ever been through, and vast amounts of information from the sensory system, and sometimes significant numbers of error, the networks responsible for precision weighting are absolutely essential as they heavily shape which forms of information should we attend to right now and which can we ignore. In this model, many forms of psychopathology result from the assumptions held in the generative model about the nature of the world and where the brain places attention or emphasis in the streams of prediction error, and sensory input. And if it seems strange that perception begins with our hallucinations about the world, nearly every other function of the brain appears to also be governed by the four elements of the predictive processing system: a generative model, predictions, prediction error, and prediction weighting. Among these other functions include motor control and virtually all movement, decision making and learning of all types, the capacity to learn and use language, all of the homeostatic mechanisms, thermoregulation, osmoregulation, energy, blood pressure, circadian, endocrine, electrolyte, pH, all of these. Also, if you follow Lisa Feldman Barrett's work, we're not born with emotions. Emotions are not universal. They're real, but they're essentially social constructs based on our cultural interpretations of affect, valiance, and arousal. So in this model, emotions are also a byproduct of your predictive brain. From this model, everything emerges from the interactions among our generative model, predictions, prediction errors, and precision weighting. Our own identities may float on top of our predictive machinery the way a mat floats on top of a pool. Predictive processing is incredibly powerful because it replaces some existing cracks in the old mirror with new glass, but it's not without its criticisms or potential cracks. First, we can acknowledge that prediction really does seem to play a huge role in brain functioning, but there's not a lot of clear empirical support for its status as the grand unifying theory of the brain. Predictive processing itself is kind of like a cultural and scientific best guess, or, if you will, the most current plausible metaphor of brain function. Second, it's an absurdly broad concept, and because of that, it's hard to falsify. And from a scientific point of view, that's a really big problem. If if your model is so big that it can be easily adjusted to fit new data, how do we ever disprove it? We also have a lot of uncertainty about exactly how it works, especially the precision weighting aspects. Other criticisms are that some people have pointed out that this view isn't new. You can find the core idea of this in Kant and von Helmholtz. Also, if the goal of a brain organized this way is to continually decrease precision error, then why don't we all just live in a dark room? That's known as precision processing's dark room problem. If we accept the predictive processing worldview, and it is a worldview, we can't get very far before we encounter some of its disturbing implications. Our classic understanding of free will is a problem in the predictive processing worldview, and you may not be down with that. If we live in a sensory corrected hallucination where so much of this happens in the order of tens of milliseconds, and our perceptions and actions are largely selected from our mostly unconscious predictions, where's the you that's deciding it? I'll only point out that free will, as classically defined, has been an experimentally debated construct in neuroscience for decades. And of course, something like free will exists, but it can't be what we've always thought that it was, and that's weird. Predictive processing suggests some weird stuff. And in many talks about it, the best and most common way to make the point is to unmask the predictive system at work. So in the next podcast, that's what we're going to do.